The physical virtual patient bed is a virtual reality medical simulation currently in development at IST's Synthetic Reality Lab located in Research Park. Still currently in development, the PVPB will potentially be used as an alternative simulated patient mannequin for use in medical training through a more interactive approach. It involves a patient shell that acts as a projection screen to display the simulated patient with customized characteristics unique to the session objectives. This, paired with touch sensing, heat generation, and pulse generation, provides a unique experience for medical students to practice effective medical diagnoses. The goal of the project was to create a user interface framework to support the operation of various components that have been incorporated into the system, including the heat and pulse generators, while also providing a well-structured framework to allow for easy additions and modifications to the systems by developers at the Synthetic Reality Lab. The pulsing device to be used is a tactile haptic feedback device. Connecting to a standard audio device on a computer, the base of an audio track is converted into vibrations through the tactile device. The emitter can then be mounted in various locations on the patient's shell, providing haptic feedback, or in this case, a pulse. To control temperature, a series of heat fans and tubes are installed under the virtual patient, which can distribute warm air to any portion of the body, allowing variations in body temperature. This system is controlled through a series of relays interfaced through USB, one of which controls fan power while the other controls the heating element. Our project is basically comprised of three sections: the front end, the back end, and the hardware. In the front end, the user interacts with the GUI, which communicates with the timeline controller. The timeline controller manages the timelines and interacts with the scenario I/O and the tactile device. Our system breaks our convention of only letting the backend talk to the hardware in order to leverage Unity's audio playing functionality for the tactile device. The scenario I/O handles the logic to save and load training scenarios. The front end and the back end each communicate with each other via request objects and response objects. In the back end, a handler distributor deserializes requests and sends them each off to the appropriate handler. Each of these handlers can perform operations on the requests and has the hardware service injected into it. They can then communicate with their hardware via the hardware API, which maintains information for how to communicate with the respective hardware component.
Since this project was meant to interface with an incomplete product, we went into this endeavor kind of expecting problems. We had to create a system that could handle both the features that were presently in place for the product and those that were still just ideas forming in the heads of the graduate students that were building this PVPB. Despite that, our main issues actually arose from trying to integrate our backend library with our front-end UI. Go figure. When the backend was first envisioned, I sort of saw it as like this agnostic, autonomous request processor that doesn't really care what it's interfacing to, since it manages no data and is run on interfaces that act as sort of contracts to whoever's accessing it. We tried to do this using an IOC, inversion of control, but Unity did not like that and generally frowns upon reflection. So after much swearing and arguing, we just cut that out. The library used to control the heating relay apparently has dependency on system.drawing, which is also on Unity's don't list, so we had to up our .NET framework to use 3.5 full instead of the subset and include very strongly worded warning, urging anyone making future alterations to be exceedingly careful, lest they upset the careful balancing act that the backend library is performing. And while this solution is sufficient, it is not ideal, as it basically contradicts the very premise of the backend, which is complete individuality for many libraries it references or is being referenced by.
So we have the hardware control through the user interface working. This means that we can turn the relays on and off, and the tactile can be controlled from the application as well. Controlling the hardware components alone isn't enough for meaningful simulations though. For this reason, we built a scenario system where different training simulations can be created, saved, and loaded. The scenarios work by using timelines for the various hardware components with keyframes on the timelines. Tweening, basically transitions, between keyframes makes simulations appear more natural. Throughout the simulation, the user interface display allows the operator to see the system state, so you can know what's going on. The quality of our solution surpasses mere functionality though. We tried to keep our solution very generic where possible, so the Surreal Lab could easily extend it. Our software client should be used whenever a connection with the PVPB is present, and control of the hardware components is desired, so basically whenever you're using the bed. It should also be used as the basis for adding additional hardware component control to the PVPB.
So here we have the patient bed. We have our computer here hooked up to both the tactile haptic feedback device as well as our heat pump. So, and I don't know if you can hear it through the video, we have our pulsing and also our heat device just kicked in, which are located down here. And yeah, thanks for watching.